A cyclist rides up a hill of vertical height 100 meters. So this is vertical displacement 100 meter in 500 seconds. That's the time at a constant speed. So when the speed is constant, it means V equals to U. Change of kinetic energy equals to 0. And there will be a change in potential energy because object is moving up the hill. The combined mass, the total mass here is 80 kilograms. The power developed by the cyclist is 200 watt. This is power in. Because if it's the power generated by the cyclist to put himself up the hill at 100 meter height. So this is the power generated by the cyclist to create a potential energy. We need to find the efficiency of the energy transfer in this system. First, why I went to the energy here, change of kinetic energy equals to 0. Why I didn't say its acceleration equals to 0, which is still correct, but because I'm not going to use it. Because the problem is talking about the power is more related to energy, since power equals a change of energy over time, or work over time. So the change of energy here is due to the change of the potential energy over time. I didn't include the kinetic energy because the speed is constant, so there is no change in the kinetic energy. If the object or the person is accelerating upward, that means that I need to add potential energy plus kinetic energy. But here the constant speed means kinetic energy equals to 0, so I'm not included in the power equation I'm going to use. So next we need to find the efficiency of any system is the power out over the power in. So first we need to find the power out. The power out is the change of potential energy over time. So this is mass times gravity acceleration times height, which is the vertical displacement over time. This is all the power out equation, mgh over time. All this is divided by the power n, which is 200 watt. So let's substitute with the given you have. The mass is 80, gravity acceleration 10, height is 100, vertical displacement over the time, which is 500 seconds. All this is divided by the power delivered in, which is 200 watt. After simplifying, we can remove a double of zeros with a double of zeros. We can, the 5 can be simplified to 2. 0 from this side can be cancelled from 0 from the other side. So 2, this one can be 10. So this is 8 over 10, or we can simply write it as 0.8, which is 80%. So the correct answer here is 80%.